Have you ever wondered what truly holds the stars together? What quiet force keeps everything from drifting apart while you sleep? Good evening, and welcome to my channel Galaxies and Goodnights, where knowledge doesn't rush. It drifts softly, like starlight across still water. Tonight, we'll take a slow, peaceful journey through one of the universe's calmest mysteries, the dark matter of space. The unseen thread that holds galaxies, stars, and perhaps even your dreams together. So before we begin, let's do something simple. Dim the lights, take a deep breath in, and let it go. You're safe here. The only thing we'll chase tonight is wonder. Tell me, where are you listening from? A city that never sleeps? Or a quiet place beneath open skies? Wherever you are, you belong to the same cosmic fabric. And if you find yourself drifting off while listening, that's perfectly fine. That's what this is meant to do. Because sometimes the best way to understand the universe is to rest inside it. Before we set sail into the dark sea of space, a small favor. If these calm explorations bring you peace, feel free to tap the little heart, subscribe, or simply stay a while. There's no rush here, only quiet discovery. Now let's begin. Let's drift into the invisible, into the quiet heart of everything, into the darkness that makes the stars shine. When you look up at the stars, have you ever wondered why they never fall apart? Why the galaxies keep spinning, silently, perfectly, as if an invisible hand holds them together? Every night, the universe performs a quiet miracle. Billions of stars, bound together, turn slowly in the darkness. Each galaxy a glowing island suspended in the deep. They spin for billions of years, so gracefully balanced that nothing tears them apart. But when scientists looked closer, something didn't add up. According to the math, the galaxies should have fallen apart long ago. The stars at the edges were moving far too fast. There wasn't enough visible matter to hold them in place. Imagine spinning a ball tied to a string. If the string were too weak, the ball would fly off into the air. In the same way, the galaxies should have scattered. But they didn't. Something invisible was holding them. Something stronger than all the stars combined. Something unseen yet everywhere. And that was the beginning of the dark matter mystery. The early astronomers were puzzled. They measured, recalculated, checked again. All the visible light, all the stars, the dust, the gas, accounted for only a small fraction of the mass needed to keep galaxies stable. There had to be something else. Not shining, not burning, but weighing everything down with quiet strength. They started calling it dark matter. Not because it was evil or scary, but because it didn't shine, it didn't play with light. It simply refused to be seen. And yet, its presence shaped everything. Imagine you're floating gently outside a spiral galaxy, watching it turn, its arms glowing like soft ribbons of light. If you could see the invisible, you'd notice a great shadowy halo surrounding it. A vast ocean of dark matter stretching beyond the stars, holding the galaxy together with a silent embrace. Without it, the stars would drift away, the spiral arms would unravel, and the galaxy would dissolve into the cold void. But because of it, because of that unseen gravity, the galaxies dance, balanced, serene, endless. So when you gaze at the night sky and see those tiny pinpricks of light, remember, what you see is not the whole story. It's only the surface. The real universe, the quiet one beneath, is invisible, gentle, and immeasurably vast. Dark matter doesn't glow, it doesn't collide, and it never complains. It simply holds, patiently, persistently, like the quiet foundation beneath a dream. It makes up most of the universe, and yet we only discovered it because things didn't behave as expected. The galaxies were misbehaving, or maybe they were just following rules we hadn't learned yet. And that's how the mystery began. a story that would stretch across decades, involving lonely observatories, patient scientists, and the quiet courage to believe in something unseen. We'll meet one of them soon, a man who first whispered the idea of dark matter to the world. His name was Fritz Zwicky, and his story began with galaxies that refused to obey. Have you ever noticed how some discoveries begin quietly, almost by accident, not with a flash of genius, but with someone staring too long at something that doesn't make sense? Almost a century ago, when telescopes were still steered by hand and photographs took hours to expose, a Swiss astronomer named Fritz Zwicky sat in a small observatory, studying a distant cluster of galaxies. It was called the Coma Cluster, thousands of galaxies drifting together, each glowing softly in the endless dark. Zwicky wasn't searching for anything mysterious. He was simply trying to understand how those galaxies moved. But as he measured their speeds, something strange began to appear in his notes. The galaxies weren't behaving. They were moving far too fast. According to the known laws of gravity, they shouldn't have been able to stay together. They should have flown apart long ago, scattered like sparks in the wind. And yet they didn't. They remained bound, orbiting as one great cosmic family. The math refused to lie. Something was missing. Something enormous and invisible was holding them all in place. Zwicky did the calculations again, carefully, slowly. He added the mass of every visible galaxy, every trace of starlight, every cloud of gas. But no matter how many times he checked, the result was the same. There wasn't enough visible matter to explain what he was seeing. It was as if the universe was hiding most of its weight. He gave that hidden mass a name, Dunkel Materie, dark matter. It wasn't meant to be poetic. It was simply descriptive. Something dark, something unseen, something real. Imagine floating far above that cluster. Thousands of galaxies like tiny lanterns glowing across a black sea. Between them, you might think there's nothing, just emptiness. But that emptiness has weight. It's filled with an invisible presence that holds every light in its place. Remove it, and the galaxies would scatter instantly, like dust blown apart by the breath of space itself. At first, few people took Zwicky seriously. He was brilliant but difficult, sharp-tongued and impatient with those who doubted him. Many assumed his measurements were off, or that he'd made some error in his calculations. It was easier to question the man than to question the universe. But time, like gravity, has a way of revealing truth. Decades later, as technology improved, astronomers began to find the same imbalance Zwicky had seen. Galaxies spinning too fast, clusters too heavy, gravity behaving as though guided by unseen hands. The whisper that began in the Coma Cluster grew louder. A quiet, consistent reminder that what we can see is only a small part of what exists. Zwicky didn't live to see his idea fully accepted. He couldn't have known how important his lonely discovery would become. But his equations planted a seed, a quiet doubt that cracked open our understanding of the universe. He showed us that the stars, beautiful as they are, only tell part of the story. The rest, the true structure of the cosmos, lies hidden beneath, silent and unseen. And though his name faded into the background of scientific history, the shadow he uncovered still surrounds every galaxy, every cluster, every particle of light. Dark matter, the invisible glue of creation, first whispered its name through Zwicky's telescope across the dark stillness of space. And that whisper has never stopped. Have you ever stared at the night sky and wondered if everything up there truly follows the same rules we do down here? The stars look calm and steady, but when scientists began to listen more carefully to how they moved, the universe started whispering something unexpected, something that would forever change how we see the dark. Years after Zwicky's lonely observations, a quiet, meticulous astronomer named Vera Rubin began her own study of the heavens. She didn't seek fame or theories that shook the world. She just wanted to understand how galaxies spun, how those vast spirals of stars, dust, and light held together as they danced in the dark. Rubin worked at night, often in near silence. Her tools were a telescope, a notebook, and a deep patience for the rhythm of the cosmos. She focused on spiral galaxies, the kind that look almost painted, elegant disks of starlight swirling around a bright center. According to Newton's laws, the stars near the middle should move faster, pulled by the stronger gravity of the dense core. The ones farther out, at the galaxy's edge, should move more slowly, just as the outer planets in our solar system take longer to orbit the sun. But when Rubin began to measure those speeds, she found something extraordinary. The stars at the edges weren't slowing down at all. They were racing around just as fast as those near the center, far too fast to be held by the visible matter alone. The outer stars should have flown off into the void. And yet they didn't. The galaxies stayed whole. She checked again. She measured more galaxies, large, small, bright, faint. Every one of them told the same quiet story. The visible stars and gas weren't enough to explain their motion. Something unseen was providing the extra gravity. Something vast, patient, and invisible. It was as though each galaxy sat inside an enormous, transparent sphere. A halo made not of stars, but of dark matter. Rubin's data turned that invisible halo from a strange idea into a measurable truth. Picture it this way: a glowing record spinning slowly in a dark room. The inner grooves whirl quickly, and the outer edges should drift lazily along. But instead, the entire record spins evenly, as though an unseen hand were keeping every groove in perfect rhythm. That hidden hand is dark matter, turning the galaxies like music that never fades. When Rubin presented her findings, many scientists were cautious. The idea of a universe filled mostly with invisible matter sounded impossible. But her data was clear, consistent, and elegant. She didn't argue with emotion or theory. She simply showed the numbers: flat rotation curves that refused to slope, stars that refused to slow. Her calm persistence did something powerful. It gave dark matter weight, not as speculation, but as fact. She showed that what Zwicky had glimpsed in a distant cluster was true everywhere, from tiny dwarf galaxies to enormous spirals like our Milky Way. And through it all, Rubin carried a quiet grace. She once said, "We are still groping for understanding." It wasn't frustration. It was wonder, the kind that keeps curiosity alive even when answers are slow to come. In her lifetime, she watched the universe grow heavier and more mysterious. She had revealed its hidden architecture, a cosmic scaffolding made not of light, but of shadow. Every galaxy became a glowing island surrounded by an ocean of the unseen. Vera Rubin didn't just confirm dark matter's existence. She humanized it. She reminded us that science isn't only about data. It's about patience, curiosity, and the courage to listen when the universe whispers instead of shouts. Tonight, as you imagine those spiral galaxies turning quietly in the dark, think of her, watching through the telescope's eyepiece, seeing the stars refuse to slow, and realizing that the darkness itself was holding them close. Because sometimes, the universe's most profound truths are not found in the light, but in what moves behind it, silent and unseen. Have you ever thought that gravity might be more than a simple pull, that maybe it's the universe's quiet way of telling us where the invisible hides? Long after Vera Rubin's calm revelations, scientists began listening even more closely to what gravity was trying to say. They realized something profound. Even if we can't see dark matter, gravity cannot keep its secrets. Wherever it exists, it leaves traces, soft fingerprints across the sky. Einstein once showed that gravity isn't a force pulling on things from afar. but the shape of space itself bending under weight. Every star, planet, and galaxy presses gently into that fabric, like marbles on a stretched sheet. The heavier something is, the deeper its dent becomes. And when light passes near it, it curves along that invisible valley. That's how we know dark matter is real. Not by seeing it, but by watching how light bends around it. Distant galaxies appear stretched, twisted, or multiplied, as though viewed through rippling glass. Astronomers call this gravitational lensing. It's one of the universe's most delicate tricks. Light, which cannot touch dark matter, still reveals its presence by obeying the shape it creates. If you could drift quietly through space and watch this happen, you'd see beams of starlight bending in graceful arcs around massive clusters of galaxies. Some of those arcs form nearly perfect circles called Einstein rings. They're like reflections in curved glass, the universe's way of sketching what cannot be seen. Through these distortions, scientists can weigh the invisible. They can map the dark halos around galaxies, trace the vast structures that stretch between them, and even measure how much of the universe is hidden. It's as if light becomes the ink and gravity the pen, together writing the story of the unseen. Sometimes, cosmic collisions reveal this story in dramatic ways. When two clusters of galaxies crash together, their visible matter, gas and stars, slows down and collides. But the dark matter? It passes straight through, untouched and unbothered. One famous example, called the bullet cluster, showed this perfectly. The glowing gas stayed behind, but the real weight of the system moved ahead, invisible yet undeniable. It was one of the clearest signs that dark matter isn't just a mathematical idea. It's a real, physical presence shaping everything we see. And yet, despite all this evidence, dark matter remains patient and private. It doesn't collide, doesn't glow, and doesn't speak in light. It only hums softly through gravity, guiding the motion of galaxies and bending the path of starlight. If you listen closely, not with your ears, but with quiet curiosity, you can almost sense it. A universe alive with unseen motion, where every shimmer of light is shaped by something deeper, something hidden. Out there, between the galaxies, gravity is still whispering the same secret. There's more here than meets the eye. Have you ever imagined what the universe might look like if you could see all of it at once? Not just the stars and galaxies, but everything that holds them together? Not the glowing surface, but the skeleton beneath? When astronomers finally mapped the universe in 3 dimensions, they expected a random scattering of galaxies, maybe a few clusters here and there. But what they saw instead was breathtaking. An immense, interconnected structure stretching across billions of light years. It looked less like chaos and more like design. They called it the cosmic web, an invisible network made mostly of dark matter, with galaxies and clusters strung along its filaments like pearls on a thread. Between those threads lie vast voids, immense empty spaces so large that an entire galaxy could drift inside one and never meet another for eternity. From a distance, this web looks strangely familiar. Some say it resembles the branching of trees, others see veins beneath translucent skin, or the neural pathways of a living brain. It's as if the universe itself is alive, pulsing with quiet gravity, connecting everything with invisible strands. In the early universe, just after the Big Bang, everything was almost perfectly smooth, a hot soup of particles and light. But tiny ripples in that soup, mere whispers of unevenness, gave gravity something to work with. Wherever there was just a little more matter than average, gravity pulled it tighter, slowly forming knots and filaments over billions of years. Dark matter did most of the work. While light and normal matter were busy colliding, scattering, and glowing, dark matter stayed calm, felt no light, absorbed no heat. It simply gathered under its own gravity, forming the first quiet structures in the dark. Later, the visible matter, gas and dust, drifted into these invisible frameworks, collecting in the densest spots until the first stars ignited. If you could see it now, you'd see galaxies glowing faintly along these dark filaments, like lanterns marking the paths of gravity. Between them, silence. Immense cosmic deserts, nearly empty, giving the bright regions space to exist, the same way pauses give shape to music. Scientists use enormous computer simulations to recreate this hidden architecture. They start with simple physics, gravity, expansion, and dark matter that moves slowly and doesn't collide. From these few ingredients, a digital universe grows, almost identical to the real one. Long filaments form naturally. Clusters bloom where the threads intersect. Vast voids open like calm oceans of darkness. It's humbling to realize that everything, galaxies, stars, even life, exists along these invisible highways built by dark matter. Without it, there would be no pattern, no connection, no order, just light scattered into nothing. The cosmic web shows us something profound. The universe isn't just a sea of stars. It's a balance of fullness and emptiness, light and silence, matter and mystery. The bright parts draw our eyes, but it's the dark framework that gives them meaning. As you drift into rest, picture that web stretching endlessly, delicate yet immense, a quiet network holding everything, including you, within its patient embrace. If you could step outside the Milky Way and look back, you might think you're seeing a bright spiral island of stars, a graceful pinwheel glowing in the dark. But that view would be deceiving. What you'd actually see is a candle burning inside a vast, invisible lantern, a galaxy suspended in something far larger than itself. This unseen structure is the galactic halo, a massive, transparent sphere made mostly of dark matter that envelopes our entire galaxy. It doesn't shimmer, it doesn't glow, yet it holds the Milky Way together like gentle, unseen hands. Without it, our galaxy's stars, including our sun, would drift away into space. To get a sense of its size, imagine the bright disk of the Milky Way, about 100,000 light-years across, floating inside a halo that stretches over 1,000,000 light-years. That's 10 times wider than everything we can see. The nearest large galaxy, Andromeda, lies about 2.5 million light-years away, close enough that the edges of its halo are already brushing against ours. The two galaxies are slowly spiraling toward each other, their halos mingling long before their stars will ever touch. It's strange to think that right now, the dark matter halos of the Milky Way and Andromeda are already dancing together, silent partners in a slow waltz that will last billions of years. When the two galaxies finally merge, their bright stars will collide and mix, but their halos will have already done most of the introduction long ago. Within our own halo, astronomers have discovered something hauntingly beautiful: stellar streams. Long trails of stars stretching across the sky like faint ribbons of light. These are the remnants of small galaxies and clusters that once wandered too close to the Milky Way and were gently torn apart by its gravity. Each stream is like a scar in the dark matter halo, a visible memory of something once whole. By studying the shape and movement of these streams, scientists can map the invisible contours of the halo itself, the way a breeze might be traced by the motion of leaves. They found that the halo isn't smooth. It has ripples, knots, and waves, subtle signatures of ancient collisions that shaped its form. The halo also acts like a cosmic regulator, balancing the life of the galaxy. Gas that falls into it from intergalactic space is heated, slowed, and stored, waiting to cool again and drift inward to form new stars. The balance between what flows in and what escapes decides whether a galaxy keeps shining or fades into quiet dormancy. In that way, the halo is more than structure, it's rhythm, a pulse that governs how long the Milky Way can breathe and create light. It's comforting to imagine the halo as a kind of cosmic cradle, invisible, steady, endlessly patient. It doesn't blaze with energy or move with drama. It simply holds everything in quiet balance. The stars may dazzle, the nebulae may glow, but the halo is the reason they endure. Tonight, when you look up at the Milky Way, that soft silver band stretching across the night, remember that what you see is only the heart of a much larger being. Around and beyond those stars lies a sphere of shadow, silent and ancient, keeping watch. The darkness that surrounds us isn't empty. It's the quiet strength that holds every star in its place, whispering across the ages, reminding us that even what can't be seen can be profoundly alive. Close your eyes for a moment and imagine yourself floating through space. Not the bright kind filled with stars, but a deeper, softer dark. No sound, no movement, no wind. And yet, you're not drifting through emptiness. You're swimming in something unseen. A silent ocean that holds everything you've ever known. That ocean is dark matter. It surrounds you, fills the galaxy, and stretches far beyond what your eyes can reach. Every atom in your body, every shimmer of light from a distant star, is quietly gliding through this invisible sea. The strange thing is, it doesn't touch you. It doesn't collide with air or stone or flesh. It simply passes through endlessly and effortlessly. Right now, trillions of dark matter particles may be moving through your body, each one ghosting through atoms as though they weren't even there. You don't feel it, but it's happening constantly. The Earth, the Sun, even the farthest galaxies, all of them are sailing through this same invisible current. The Sun, for instance, is racing around the center of the Milky Way at about 220 kilometers per second, fast enough to circle the entire galaxy once every 230 million years. And as it moves, it carries us with it through the dark matter halo, gliding like a small ship across a calm, invisible sea. If dark matter could suddenly glow, the sky would transform before your eyes. You'd see a faint, spherical shimmer surrounding the Milky Way, stretching hundreds of thousands of light years beyond the stars. The galaxy would appear as a delicate candle burning at the center of a glass globe, the dark matter forming a vast translucent shell around it. Astronomers can't see this directly, but they can trace it. They watch how stars move, how galaxies spin, how the light bends as it travels across space. From those motions, they reconstruct the shape of what they can't see. Like reading the ripples on a pond to know that something unseen just passed beneath. And one of the most poetic clues comes from stellar streams, those thin ribbons of stars torn from smaller galaxies. As they twist and curve around the Milky Way, their paths reveal the shape of the invisible halo, like cosmic handwriting across the night sky. Each glowing streak is a note in the quiet symphony of gravity, showing where dark matter's hand has passed. When you think about it, it's oddly peaceful. The universe is mostly dark, and yet it's that darkness that holds everything steady. The stars spin safely in their orbits because of it. The galaxies stay whole because of it. Even the path of your own sun, and every sunrise you've ever seen, exists because an unseen gravity gently cradles it all. So when you gaze up at the Milky Way tonight, remember that what you see is only the surface, the glowing crest of an immense and silent tide. Beneath that shimmer lies a calm ocean of darkness, stretching endlessly, holding every spark of light in its quiet embrace. We are not above it nor outside it. We drift within it, small lights carried by a sea that never sleeps. What if the universe was whispering, but we just didn't know how to listen? That question has driven generations of scientists to dig deep beneath the earth, into silent caverns and abandoned mines, searching not for gold or gemstones, but for the quietest thing imaginable, the soft tap of an invisible particle. Because if dark matter truly fills the cosmos, then it must also flow through us, through the earth, and through every detector we build. Somewhere, in all that motion, one tiny collision could happen. A dark matter particle brushing against an atom and leaving behind a whisper of energy. To hear that whisper, scientists go underground, far away from the noise of cosmic rays and surface radiation. They build vast detectors filled with liquid xenon, cooled to near absolute zero, where even the faintest flicker of light can be captured. Imagine a cathedral-sized chamber buried a mile below the surface, silent except for the soft hum of machines, waiting patiently for the universe to speak. One such experiment, called LUX Zeppelin, rests deep in an old South Dakota gold mine. Inside its quiet tank, xenon atoms float in perfect stillness. If a dark matter particle ever collides with one, it produces a microscopic flash of light, a moment so brief that it lasts less than a billionth of a second. Dozens of detectors surrounding the chamber wait like monks in meditation, recording every pulse of light that breaks the silence. Other experiments take different approaches. Some use ultra-cold crystals chilled to temperatures so low that even the smallest vibration, smaller than the fall of a snowflake, can be heard. Others use vast underground caverns filled with noble gases or supercooled liquids, each designed to detect a single, sacred tremor in the stillness. But dark matter is polite in its invisibility. It rarely interacts, rarely announces itself. These detectors can wait for years, even decades, without a clear signal. Every faint flicker must be tested, retested, and questioned. Was it a cosmic ray that slipped through? A stray vibration? A false alarm? Science here is a practice of patience and humility. And yet, there's something beautiful about that waiting. Each quiet night in those labs feels like a small act of faith. Faith that the universe will one day murmur back. The scientists who tend these detectors aren't surrounded by grandeur or noise. They work in the dark, often alone, maintaining their instruments with the care of gardeners tending invisible seeds. They know that when, not if, but when the first true signal comes, it will be a moment of breathtaking transformation. One tiny flash of light, one perfect ripple in the silence, and humanity will have heard the heartbeat of the unseen universe. Until then, they keep listening. The detectors remain in their still vigil, buried beneath rock and time, waiting for that one soft touch from the dark. And above them, life continues. People sleep, oceans move, stars burn. All unaware that far below, someone is quietly listening to the universe breathe. Have you ever looked at the night sky and wondered if it was trying to tell you something? Not with words, but with a faint shimmer hidden between the stars? For all the quiet listening that happens underground, another kind of search is taking place high above, among telescopes and satellites that study the heavens. Because if dark matter won't reveal itself on Earth, perhaps it's out there, leaving clues written in light. This is called indirect detection, the art of watching the universe for signs that something invisible has stirred. Scientists know that if dark matter particles ever collide, they might briefly transform into energy, releasing faint bursts of gamma rays, positrons, or neutrinos. The challenge is to spot those flickers among the cosmic noise. The best place to look? The center of our galaxy. A crowded, energetic region swirling around a supermassive black hole, where dark matter is thought to be densest. For years, telescopes like NASA's Fermi Gamma Ray Space Telescope have been staring into that glowing heart, searching for a soft, persistent light that doesn't belong to any star or nebula. And they've found something strange, a faint glow, too strong to ignore, too mysterious to explain. For a while, scientists wondered if this could finally be it, the afterglow of dark matter particles colliding in the heart of the Milky Way. But the universe loves riddles. Others argued that the signal might come from spinning dead stars, tiny pulsars flickering too faintly for us to see individually, but bright enough together to mimic the glow. Every time the data seemed to whisper yes, another voice of caution followed. Perhaps not yet. Beyond the Milky Way, astronomers turned their attention to the dwarf galaxies, small, faint companions orbiting us like quiet shadows. These galaxies are made almost entirely of dark matter, with very few stars to confuse the picture. If there were any place to catch a clean signal, it would be there. Dozens of telescopes have scanned those galaxies, hunting for a subtle rise in gamma rays, a faint hum of energy, a soft breath in the silence. And sometimes they see hints, small ripples in the data that almost form a pattern before dissolving again, like footprints washed away by cosmic tides. It's easy to imagine the frustration, years of watching, measuring, hoping, only for the universe to remain playfully quiet. But in that quiet, there's meaning. Every non-detection narrows the mystery, refining the path forward. The absence of light becomes part of the map. And so the search continues. New observatories, like the Cherenkov telescope array, promise to see deeper, sharper, clearer, to separate the whispers of dark matter from the symphony of the cosmos. There's something profoundly poetic about this pursuit. We're looking for shadows made of light, for the faintest echoes of the unseen. The darkness itself might one day betray its presence by the gentle light it releases. It's not failure when the sky stays quiet. It's conversation, the universe answering in its own patient language. Not yet, not here, but keep looking. Every telescope scanning the heavens, every data point checked twice, is a reminder that the cosmos doesn't reveal its secrets through noise, but through silence. Somewhere in that silence, hidden among the stars, the truth about dark matter waits. Still, calm, and eternal. What if the answers to the universe's deepest mysteries weren't hidden in silence, but in collisions, moments of unimaginable energy where particles crash together and, for an instant, reality reveals its secret script? If dark matter won't speak in light or whisper underground, physicists have chosen another path, to create the conditions where it might appear. Not by waiting, but by recreating the chaos of the early universe itself. This is the idea behind particle colliders, enormous machines that smash protons together at nearly the speed of light. The largest of them all, the Large Hadron Collider, LHC, sits beneath the French-Swiss border, a 27-kilometer ring of magnets and detectors buried deep underground. Within it, human beings have built a kind of artificial dawn, recreating the heat and density of the universe as it was a fraction of a second after the Big Bang. When those collisions happen, for a heartbeat shorter than time itself, matter transforms into pure energy, and from that energy new particles are born. Most vanish in the blink of an eye, leaving behind trails of light and charge that physicists record and analyze. But sometimes, something doesn't add up. The energy going in doesn't perfectly match what comes out. Something is missing. That missing piece, that invisible energy, could be the first trace of a dark matter particle escaping into the unknown. It's not seen, not heard, but it leaves a mathematical echo, a space where something should have been. To catch these moments, detectors like ATLAS and CMS record billions of collisions every second. They sift through mountains of data, looking for the faintest signs of imbalance, the whisper of an unseen guest. Each missing bit of energy is examined with the care of an archaeologist dusting off ancient bones. So far, no unmistakable signal has appeared. But the search has not been in vain. Every run of the collider brings clarity. It rules out false paths, narrows the range of possibilities, and refines the questions. The process is slow, deliberate, and profoundly human, the pursuit of something that resists being found. There's a kind of poetry in this method, using collisions, moments of incredible violence, to search for the quietest, calmest substance in the universe. Inside that controlled chaos, scientists look for serenity, the still, unseen particles that built the stars, the galaxies, and us. Each flash of light in the collider is like a miniature universe, born, expanding, fading. And in each one, perhaps, lies the faint echo of the same darkness that shaped everything we see. Someday the data might reveal a new kind of particle, one that doesn't glow, doesn't collide, but weighs on space just enough to sculpt galaxies. When that day comes, it won't just confirm dark matter's existence. It will connect us to the moment creation itself began. Until then, the LHC hums quietly beneath the Earth, a ring of light chasing itself through the dark, echoing the dance of galaxies above. Each collision a heartbeat, each silence a promise. And within that promise, the universe waits, patient as ever, to be understood. What if, after all this searching, we've been asking the wrong question? What if the darkness isn't something added to the universe, but something different about the way it moves? Not everyone is convinced that dark matter is the missing piece. Some scientists have dared to ask, what if gravity itself doesn't behave the way we think it does? Maybe, they suggest, the cosmos isn't hiding anything at all. Maybe we've just misunderstood its rhythm. This idea first took shape in the 1980s when physicist Mordechai Milgrom proposed something radical, a theory called MOND, or modified Newtonian dynamics. Newton's laws had worked beautifully for centuries, describing falling apples, orbiting planets, and the pull between stars. But when astronomers looked at how galaxies rotate, something didn't fit. The stars at the edges were moving too fast, faster than gravity alone should allow. Instead of assuming invisible matter was holding them together, Milgrom asked, what if gravity simply changes when it gets very weak? In MOND, gravity doesn't fade away as quickly as Newton predicted. At the outer edges of galaxies, where accelerations are tiny, it stays just a bit stronger. That small tweak could explain why galaxies hold together without any extra mass at all. A daring idea, elegant, simple, almost poetic. And for a time it worked beautifully. In many galaxies, MOND predicted the exact speeds of stars better than the standard dark matter model. It even explained a strange pattern known as the Tully-Fisher relation, which links a galaxy's brightness to how fast it spins, as though every galaxy were humming to the same invisible tune. But the universe, as always, resists easy answers. When scientists tried to apply MOND to galaxy clusters, it stumbled. The pull of gravity there was far too strong to be explained by modified rules alone. Even MOND had to sneak a little unseen matter back into the picture. A quiet irony that didn't go unnoticed. Then came the cosmic microwave background, the faint afterglow of the Big Bang, carrying information about the early universe. Its delicate ripples matched perfectly with the predictions of dark matter, but not with MOND. The modified laws worked for some galaxies but failed at the grander scale. It was as if MOND could describe a single song beautifully but struggled to play the whole symphony. Still, MOND changed the way scientists think. It reminded everyone that gravity, even Einstein's elegant version, might not be the final word. Other theories, grouped under modified gravity or MOG, followed. Some imagine that gravity weakens or strengthens depending on the scale of the universe. Others propose entirely new forces, hidden fields that tug gently on space itself. A few even dream that dark matter and dark energy could be two faces of the same deeper principle. Even though dark matter remains the stronger theory, MOND and its cousins are far from discarded. They're part of science's heartbeat, the constant questioning, the refusal to rest on certainty. They whisper a simple truth. Maybe the cosmos is not lying to us. Maybe it's just more subtle than we thought. In a way, these theories are acts of humility. They remind us that every equation, every model, is just our best attempt to translate the universe's poetry into numbers. Sometimes we get the rhythm wrong, But even that wrongness moves us closer to understanding. And so, the debate continues between gravity as we know it and gravity as it might be. Between the visible and the invisible, the measurable and the imagined. The universe, it seems, loves its secrets. Not to hide them, but to keep us curious. Have you ever looked up at the night sky and realized that everything you can see, every glowing star, every swirling nebula, every galaxy shining across the dark, is just a small fraction of what's really there? If you could somehow weigh the entire universe, all the brilliant stars and galaxies would barely tip the scale. The truth is astonishing. Everything visible, everything we've ever touched, seen, or measured, makes up only about 5% of the cosmos. The rest, an overwhelming 95%, is invisible. About 27% of that invisible mass is dark matter, the silent architect of structure, while the remaining 68% is dark energy, the quiet force that pushes the universe apart. Imagine standing inside a vast cathedral, so immense its walls vanish into shadow. The beams of sunlight streaming through the stained glass. Those are the stars, the visible 5%. Beautiful, dazzling, but small. The pillars that hold up the ceiling and the air that fills the room. That's the dark matter and dark energy. They don't shine, but without them, the cathedral would collapse. This realization reshaped how we understand existence. The universe isn't mostly made of light. It's mostly made of quiet. Yet that quiet gives everything form and meaning. Dark matter acts as the scaffolding of the cosmos, the invisible framework on which galaxies gather and stars are born. Without it, there would be no grand spiral arms, no clusters, no galaxies at all. Just scattered dust adrift in endless night. Dark energy, meanwhile, works in opposition, gently stretching space itself, driving galaxies apart like leaves drifting on a calm but widening river. And somehow, between these two forces, one that binds and one that expands, lies balance. The universe exists in perfect tension. Gravity pulling inward, expansion pushing outward. Light caught between the two. Astronomers often say the universe is elegant. Not because it's simple, but because its complexity fits together like music, gravity providing the rhythm, dark energy the melody, and dark matter the harmony that holds it all together. Even the silence is part of the song. The thought can be humbling, that the atoms in your body, the starlight that warms your face, the air you breathe, all come from that tiny sliver of the visible universe. We are the rare, luminous edge of something infinitely larger and unseen. Yet there's comfort in that too. Because even though we're small, we're not separate. The same dark matter that holds galaxies together also holds us. The same unseen energy that expands the cosmos also flows through the fabric of the space around us. The universe is not just light scattered through darkness. It's light woven into darkness, each giving the other purpose. Without the unseen, the seen could not exist. Without the silence, there would be no song. So the next time you look up at the stars, remember, you're not just seeing distant suns. You're seeing the visible skin of a much deeper reality. A cosmos where the invisible carries the visible, gently, patiently, across eternity. Have you ever wondered how the story of the universe ends? Not in fire or destruction, but in silence. A silence so deep it feels like rest. Right now, we live in what might be called the age of light. A brief, golden moment when stars still burn, galaxies still glow, and the night sky still sparkles with memories of creation. But like every story, this one too will one day grow still. Billions of years from now, the brilliant stars that fill our skies will begin to fade. The blue giants, massive, fierce, and short-lived, will burn out first, leaving behind cold embers and drifting gas. Smaller, gentler red stars will endure far longer, glowing softly for trillions of years, like candles flickering at the edge of eternity. But even they will eventually fade into blackness, cooling into silent remnants called black dwarfs, invisible to any eye. The galaxies themselves, once vibrant cities of light, will grow dim and hollow. Stars will die faster than new ones can be born, and slowly, the cosmos will slip into its long twilight. It won't be sudden, just a quiet dimming, as though someone is gently lowering the light of existence. But not everything will vanish. The dark matter halos that cradle galaxies will remain. Their invisible gravity will continue to sculpt the cosmos, preserving the ancient outlines of galaxies long after the last star has gone dark. They are the quiet architects of eternity, the cosmic ruins that outlive all brightness. Meanwhile, dark energy will keep stretching space, carrying galaxies farther and farther apart until their light can no longer reach one another. Each cluster will become a lonely island, drifting through an ever-expanding sea. For any being that might exist then, the night sky will hold only a handful of faint stars, the rest of the universe, lost beyond the horizon of sight. Over unimaginable spans of time, even the black holes will begin to fade, releasing their energy in faint whispers of radiation, the last sighs of gravity itself. The universe won't end with an explosion, but with a slow exhale, a long unwinding into stillness. And when the final light goes out, when the last photon drifts into infinite distance, the dark matter will remain, silent, invisible, unchanging. The same quiet framework that once held galaxies together will continue to exist, patient and eternal, preserving the memory of everything that ever was. Sounds melancholy, but it isn't. There's a strange peace in it, the idea that the universe doesn't die, it simply rests. Creation doesn't vanish, it just becomes still. The brightness that once filled the skies will return to the dark it came from, like a song resolving softly to silence. In that distant future, the cosmos will be a vast, quiet ocean of darkness, but not empty. It will still carry the structure of what once shone, the graceful shapes of galaxies lingering like constellations of memory. And somewhere in that eternal calm, perhaps in ways we can't yet imagine, something new may stir again, a faint echo of light returning after an endless sleep. Because the universe has always been creative, patient, and cyclical. It doesn't rush, it simply transforms. And even in the deep night, it whispers the same truth it always has. The dark is not an ending. It's the beginning of something we've yet to see. When you look at the night sky, it's easy to think of darkness as the backdrop, a blank canvas upon which the stars are painted. But what if it's the other way around? What if the darkness isn't behind the light at all, but holding it? For as long as humans have looked upward, we've been taught to celebrate the light, to follow it, to chase it, to overcome the dark. Yet in the vastness of the cosmos, that belief begins to soften. Here, light doesn't conquer darkness. It depends on it. Every shining star, every glowing nebula, every galaxy owes its beauty to the silent framework that gives it shape, to the dark matter that holds it in place. If you could see the true structure of the universe, you wouldn't see a void filled with scattered stars. You'd see a vast tapestry woven from threads of gravity, dark filaments stretching endlessly, linking galaxies like beads of light along invisible strings. The brightness isn't fighting the darkness. It's resting in it, like fireflies in the calm of night. Darkness is not absence. It is structure. It is the unseen geometry that allows everything else to exist. Every beam of light you've ever seen was sculpted by this quiet architecture. The dark matter halos that cradle galaxies, the cosmic web that binds them, the gravity that shapes their orbits. Even the light from your own sun follows invisible curves carved by the unseen. We often think of discovery as a process of illumination, shining light into the unknown. But perhaps the universe is teaching us a gentler lesson, that some truths are meant to be felt, not revealed. The cosmos is not a war between brightness and shadow. It's a partnership. Light dances only because darkness keeps the rhythm. There's a serenity in that thought, that what we cannot see is not our enemy, but our foundation. The unseen doesn't demand to be understood. It simply is. It waits, patient and steady, letting the stars burn and fade, letting the galaxies spin and rest. When you close your eyes at night, you aren't turning away from the world. You're returning to it. You're aligning with the same quiet calm that fills the universe between the stars. The dark doesn't erase the light. It completes it. So, the next time you stand beneath the night sky, try not to look only at the stars. Feel the space between them, the deep, velvety stillness that stretches forever. That's the true shape of the cosmos. The stars are the embroidery. The dark is the fabric that holds it together. Light gives us wonder, but the dark gives us peace. And perhaps the universe's most beautiful secret is that we need both in the sky and in ourselves to truly see. Have you ever felt small under a starry sky? Not in fear, but in awe, as if the whole universe were breathing around you? That feeling is the quiet truth of existence. We are not just witnesses to the cosmos. We are part of it, woven into the same invisible fabric that holds galaxies, stars, and light itself. The atoms in your body were born in stars, but those stars were guided by the gravity of dark matter halos, the unseen architecture that shaped their birth. That means you, too, are partly made of the dark. We often speak of the universe as if we stand outside it, looking in. But the truth is gentler. We are inside the story. Every heartbeat, every breath, every thought is unfolding within the same cosmic rhythm that spins galaxies and lifts suns from dust. The unseen is not out there. It is within and around us, holding us the same way it holds the stars. Dark matter may be invisible, but its influence is everywhere. In the calm orbit of the Earth around the Sun, in the steady balance of the Milky Way, in the quiet order that allows life to exist. It's as though the universe chose silence as its foundation so that light could play freely above it. And maybe that's what makes the cosmos so human, its balance of mystery and meaning. The visible gives us wonder. The invisible gives us belonging. Together, they remind us that we're not separate from the vastness we see. We're threads in the same endless tapestry. When you stand under the night sky, you're not looking at something distant. You're standing inside it. The stars are not above you. They're around you, wrapped in the same halo that cradles our galaxy. The air you breathe, the space between atoms, the gravity that keeps your feet on the ground. It's all part of that same unseen framework. There's peace in that thought, that even in the unknown, there is connection. That the darkness doesn't divide, it unites. The universe doesn't ask to be understood completely. It simply invites you to notice the light, the stillness, the quiet in between. Every night you look up, it's whispering the same reminder. You belong here. You are made of stars and silence. And the darkness that holds the galaxies holds you too. When all the science is done, when every equation has been tested and every telescope switched off for the night, there's a deeper kind of understanding that remains, not in data but in feeling. The universe, for all its vastness, is peaceful. Not empty, not cold, but calm. Like a great ocean that has finally settled after an infinite tide. The dark matter still moves quietly beneath it all, guiding the invisible currents, holding together what light has long since forgotten. In that silence, there is no hurry. Stars rise and fade. Galaxies grow and drift apart. Everything changes, and yet nothing is truly lost. The darkness that began it all continues to cradle what remains. Patient, enduring, unbroken. You can almost imagine the cosmos breathing, a slow inhale of gravity and an endless exhale of expansion. And somewhere in that rhythm we exist, tiny flickers of awareness within the great stillness. We measure it, name it, study it, but in truth we are part of it. The quiet between the stars is the same quiet that lives within us when we close our eyes. When you think of the universe, try not to picture chaos or noise. Picture balance, a harmony between light and dark, movement and rest, knowing and mystery. The galaxies that spin, the matter that hides, the space that stretches. All of it is one long, patient melody. Perhaps that's what makes dark matter so beautiful. It never competes for attention. It holds everything together and asks for nothing in return. It is the universe's heartbeat, constant, invisible, and kind. So as the night deepens and the stars find their places again, let the thoughts settle softly. You are surrounded by this same stillness. You are made of its light. And when you rest, you are simply returning to the rhythm that shaped the stars. The darkness above you is not a void. It's a home. The universe hums in quiet symmetry, and you are part of its song. There's a strange peace in realizing we may never fully understand the universe. For centuries, we've tried to light up every shadow, measure every movement, and name every mystery. But the cosmos doesn't rush to explain itself. It reveals things slowly, like a teacher who smiles when you finally stop interrupting and just listen. Dark matter and dark energy are reminders that not everything that matters can be seen. They are the universe's way of keeping wonder alive. Because if we knew it all, there would be no reason to look up at the night sky with that small ache of curiosity, that quiet question that has guided humanity since the first fire was lit on Earth. The truth is, not knowing is part of the design. Keeps us searching, imagining, dreaming. Science is not about conquering mystery, it's about learning to live with it gracefully. Each discovery is not an ending but a doorway to something deeper. We measure the rotation of galaxies, map invisible webs, and build machines to listen for whispers in the dark. But behind all those equations and experiments lies something profoundly human, a desire to feel connected to everything. To believe that even in all this vastness, we have a place. When you look up at the stars tonight, try not to think of them as distant or unreachable. Think of them as reflections, quiet reminders that the same forces holding them together are holding you too. You are not outside the mystery. You are part of it. And maybe that's the most beautiful truth of all, that we live inside the question, not waiting for the answer, but learning to rest within it. Because sometimes the most profound kind of knowledge isn't about knowing more. It's about feeling small, still, and perfectly at peace with the fact that the universe, in all its silence, has already said enough. Imagine for a moment that you're floating just beyond the Milky Way, far enough to see the whole of it at once. You'd see a glowing spiral of stars, calm and beautiful, suspended in an invisible glass sphere. The light would seem to drift in the darkness, delicate and self-contained. But that sphere, the unseen halo of dark matter, is what holds the lantern steady. Without it, the galaxy would unravel like a thread in wind. This image, quiet and complete, is where our journey began. A lantern of light surrounded by a cradle of shadow. And now, after tracing the universe from its bright beginning to its slow, graceful stillness, we return to that picture, the balance between what shines and what doesn't. Everything you've learned, every thought of dark matter, halos, gravity, and galaxies, leads back to this one truth. Light and dark are not rivals. They are partners. The seen and unseen are not opposites. They are two halves of the same whole, endlessly weaving reality together. Dark matter does not demand attention. It moves without motion, speaks without sound. It lets the stars take center stage, content to remain in the wings, holding the structure of the story. It is the universe's act of quiet generosity, the unseen support that allows brilliance to exist. And in a way, it's the same with us. The thoughts we never say, the emotions we carry silently, the memories we hold alone, they're our own kind of dark matter. They don't show, but they shape everything we are. The visible world of words and action rests gently on that invisible foundation. So when you look up tonight and see that soft river of starlight, the Milky Way stretching across the dark, try to see the full picture. The stars are not floating in emptiness. They are resting inside something vast and unseen, something that has carried them for billions of years. The same goes for us. We drift in something unseen. Call it gravity, time, mystery, or grace. It holds us, connects us, guides us quietly through the endless night. The story of dark matter isn't just science. It's a reflection of being, a reminder that what's invisible is often what keeps everything alive. So close your eyes and picture it once more. A lantern glowing softly inside a glass sphere. The light flickers, the darkness holds it, and together they make the universe whole. If you could listen closely enough, beyond the hum of stars, beyond the faint echo of ancient light, you might hear it, a rhythm that never stops. It's not loud. It doesn't thunder or roar. It's the soft pulse of the universe itself, a heartbeat made of gravity and silence. That pulse is everywhere, in the slow swirl of galaxies, in the drifting of nebulae, in the quiet tug that keeps planets in their paths. Even now, as you sit here, that rhythm moves through you. Steady, patient, unhurried. You are, quite literally, beating in time with the cosmos. Dark matter doesn't shout its presence. It's not the kind of truth that announces itself with spectacle. It prefers the language of balance, the way everything holds together just enough, never too tightly, never too loose. It lets the stars dance without falling apart, lets the universe stretch without breaking. Sometimes we think of infinity as cold or distant, but maybe it's more like a long breath, an inhale that forms galaxies, an exhale that carries them apart. Creation and expansion, light and dark, all moving in harmony. The same way your lungs move when you breathe, the same way your heart moves as it keeps time. Every atom in you was born from a star, yes, but the pattern that arranged those stars, the invisible gravity that gathered them, held them, released them, that same pattern lives in you too. You are not simply made of the universe. You are a continuation of it. If dark matter could sing, it wouldn't be a song of noise. It would be a hum too low to hear, a frequency that only your soul could feel, something ancient, comforting, familiar. Maybe that's why quiet moments feel sacred, why silence feels full instead of empty. Somewhere deep inside, we recognize that stillness. We've known it since before we were atoms. The universe doesn't rush. It doesn't compete. It simply expands, gently, endlessly, guided by forces we can't see but somehow trust. That's the lesson hidden in the dark. That what truly sustains us often asks for no attention at all. As you rest tonight, imagine that pulse, the slow heartbeat of forever, echoing softly through you. Feel it in your breath, your chest, the quiet around you. You're not just in the universe. You're part of its rhythm. And as it breathes in silence, so do you. If you stay up late enough, long after the last voices fade and the world grows still, you'll notice that the night has a softness to it. The same softness that fills the space between galaxies. A silence that doesn't feel empty, just waiting. The stars you see tonight are ancient, but they are also fleeting. Their light has crossed unimaginable distances to reach you, some shining from a time before Earth had even formed. And yet, one day, even those lights will dim. The universe, in its patient rhythm, will guide them into rest. It won't be tragic. It will be peaceful. One by one, the stars will finish their long songs and fade into the dark. The galaxies will drift apart, their halos still holding invisible hands. The cosmic web, that vast lace of gravity and quiet matter, will remain steady and serene, a memory of creation that never truly ends. Dark matter will still be there, the same gentle force it has always been, unbothered by time, untouchable by decay. It will cradle what remains, like an ancient guardian who never sleeps, ensuring that even in stillness, the universe keeps its shape. In the farthest future, long after the last photon fades, all that will remain is this invisible structure, the framework of existence itself. A whisper of gravity, a trace of pattern, a silence so complete it becomes beautiful. But tonight is not that faraway night. Tonight the stars still burn. They still hum in their orbits, still send their light across the dark to meet your eyes. The same dark matter that will one day carry them into quiet eternity is carrying you too, gently, safely, through your own small journey in time. So as you drift toward sleep, let yourself feel that connection. The same calm that surrounds the stars surrounds you. The same silence that holds galaxies holds your breath. You are part of that great stillness, the dark scaffolding of everything that is, was, and will be. The universe isn't asking you to understand it tonight. It's just asking you to rest with it. Close your eyes. The galaxies are still turning. The stars are still singing. And somewhere, in that endless darkness, the universe is whispering back, "You are home."